Today we're talking about elliptical orbit, specifically the energy of elliptical orbit. That's why we're here today to derive it. Alright, and this is a very long, fat derivation, so don't blame yourself if you don't get it on the first try. Floop. That's not a nice enough ellipse. That's fine. So, here is our orbit around a star. And an ellipse, the star will usually be at the foci, will always be at the foci. So, the planet is going to rotate, or it's going to go all the way around this orbit, then return back. And you might have noticed, since the ellipse varies, there is a point where it's closest to the sun and the point where it's farthest from the sun. Let's make it a little less thick. So we call the point where it's closest to the sun the aphelion. Well, no, we don't call it that. But we call the distance between this point and the sun the aphelion. So, no, not the aphelion, the perihelion. Because it's very close. It's mucho close. And this is what's known as the aphelion. And we're going to call this R-ap, or R-A. I'm going to use a capital A. And RP for perihelion. And with this comes some variance. Now, specifically, what do I mean by that? That sounds very weird. So, the thing is, angular momentum conservation is important. So, MV initial, or MVA, RA, has to be equal to MVP, RP. What is VP and what is VA? Well, VP, or VA, is going to denote the velocity at the perihelion, and the aphelion, sorry, I keep confusing them, and VP is going to denote the velocity at the perihelion. So, if we cancel these out, we get VP over VA times RP over RA is equal to 1. Or in other words, VP over VA is equal to RA over RP. What does that mean? Well, RA is way bigger than RP. So that means that VP must be way bigger than VA. And that's what's shown in this diagram. Alright, so now let's get started with our derivation. So for this, we're going to be using two principles. COE, conservation of energy, and COAM, or as my brother likes to call it, COM, conservation of angular momentum. So, what is the conservation of energy? Well, if you're going to the F equals ma, you should know this. And if you don't know this, you're hopeless. So, the conservation of energy says mechanical energy initial equals mechanical energy final. We know the beep, we know the boop. And here, since we're talking about just mechanics, I'm pretty sure the entire F equals ma is only mechanics. We're only considering U, in this case UZ, we're not talking about springs, and K. So, U plus K equals U plus K. Now, for one of our points, we're going to be using the aphelion, and for another, we're going to be talking about the potential and kinetic at the perihelion. Oh, why do I keep confusing DNA? Okay, so we get mg RA. Well, no, we can't use mg. Because we're in outer space and we're dealing with very large distances, we have to use our alternative formula. Minus d, big M, little m, over r. And our r specifically is r, well, since we have the a on this side, I'll just use ra. Plus k, which is half mva squared. And then we have up, which is minus dmm over rp, and then plus kp, which is half mvp squared. I know you have that hidden inside urge to cancel out every single one of these small m's. But don't do it, because that's going to make the simplification later on way harder. And trust me, I've tested. So, the second principle we're using is COMB, or conservation of angular momentum, which says angular momentum initial is angular momentum final. And if you don't know this one and you're trying for the F equals ma, you might have some hope left. So just keep trying. So angular momentum initial, angular momentum final. So angular momentum is m and v cross r, and the cross is basically a way to add two vectors to get another vector. So in this case, it's just going to be the magnitudes of v and r times sine theta. But here's the thing about the sine theta. The r is always perpendicular to v because our tangential velocity is perpendicular to the path. So what is our sine theta? Sine 90. What's sine 90? 1. So we can essentially disregard this. So we have mvr equals mvr. So mv initial r initial equals mv final r final. Once again, do not cancel the m's, please. It's going to be mucho important later on. So here we have mva ra equals l, and mvp rp is also equal to l. So that means that va is just l over mra, while vp is l over mrp. So now, let's take that and plug that into here. And what do we get? Minus gmm over ra. And after this, it's just a lot of hard algebra. So there's really no key realizations left. You just have to be diligent on how you simplify. And for VA, we're just going to be taking the L over MRA and squaring it. You get L squared over M squared RA squared. And now we just cancel these out, and we get on the other side. And yes, you can satisfy your urge to cancel these fellas out. Minus GMM over RP plus half M. And we just plug in our equation for VP, which is L over MRP. So L squared over M squared RP squared. And now we once again satisfy the urge to cancel. And now, what do we get? Minus GMM over RA plus L squared over 2MRA squared equals minus GMM over RP plus L squared over 2MRP squared. Now, you can factor a few things here. Now, what are those factors? Well, let's bring this fellow over to this side and this fellow over to this side. We got L squared over 2MRA squared minus L squared over 2MRP squared equals GMM over RA minus GMM over RP. Now, I think you see what we can do here. We can factor out L squared over 2M here is equal to GMM here. And for GM, we have 1 over RA minus 1 over RP. For this, we have 1 over RA squared minus 1 over RP squared. This might look a little familiar to you because it's just the difference of squares. So that just gets you 1 over RA squared minus, no, not RA squared, just RA, minus 1 over RP. And then on the other one, 1 over RA plus 1 over RP equals GMM times 1 over RA minus 1 over RP. Do you see where we're going here? I hope you do. Because now, what do you think we do? Tell me, what do you think we do? No, you! Seriously, behind the camera, tell me.
Alright, so
what do we do here to simplify?
let's see whether you can cancel 1 over RA minus 1 over RP.
And we can! That's the key part. And now all we have to do is make this fella into one fraction because it looks better. L squared over 2M times, and this should be pretty simple, RP over RA RP plus RA over RA RP equals GMM. In other words, L squared over 2M equals GMM RA RP over RA plus 8RP. Alright, and now what do we do? You might think, hey, we're stuck. Well, we wanted to find the energy of an elliptical orbit, right? Well, to do that, we need to find either this side or that side. And you can just pick and choose randomly. Doesn't quite matter which side you choose. So, what should I choose? Aphelion or perihelion?
Aphelion.
Okay. Aphelion. So we take this. Minus GMM over RA plus half MVA squared. Minus GM RA minus plus half MVA squared. And that's our energy, right? Alright. Now, we do the same thing that we did before with the L. We get minus GMM over RA plus M times L squared divided by M squared RA squared. And then, we have the 2 from the 1/2. We can cancel these out. And voila! We have, what do we have here? Plus L squared over 2M times 1 over RA squared. Alright, so now what we do is we plug this fella in. And what do we get? For L squared over 2M minus GMM over RA plus GMM RA RP over RA plus RP times 1 over RA squared. And we cancel, and eventually we get minus GMM over RA plus GMM RP over RA plus RP. Alright, so what are we going to do? Here? Well, the key realization to make is that RA plus RP is just the semi-major axis. Well, not the semi-major axis, the whole major axis. And if the semi-major axis, which is half of that, is expressed as A, then the whole thing can be expressed as 2A. I think I'm missing, oh yeah, did a little oopsie here. And you put that. So now you have minus GMM over RA plus GMM RP over RA